Lotte,
Hi,
I'm so sorry.
that's okay.
How are you?
I'm good. How are you?
I'm fantastical. What's
Great.
going on with you? You doing all right?
I'm good. I'm starting revision now. So
You're starting what?
I've done all my coursework now, so it's just revision.
Revision means review.
Yeah.
So is that a relief for you?
Yeah. I kind of like revising or reviewing. So it's
Yeah, good for you.
yeah.
Good for you.
Yeah.
Okay, so let's see. Can you go another half hour beyond this so we get a full hour in,
Yeah.
or do you want to stop?
I can. Yeah.
Okay. All right. So let me just get this going. Let's see. Okay. So, oh, all you see is my ugly picture. And so now you can have my ugly live picture. How's that?
Don't be mean to yourself, Dave.
Listen, nobody understands my self-defecating sense of humor.
Okay. I understand now.
Do you get
As long
it?
as it's a joke.
See,
As long as it's a joke.
do you see what I did there?
Yes.
What did I do?
You deflected what I
Oh,
said.
no, I said, no one understands my self-defecating sense of humor.
I don't know what that means.
The correct word is deprecating.
Right, but I don't know what defecating means.
Okay, so, okay, well, I'm not going to tell you what it means. You have to look it up. DEFECATING,
Okay.
I think.
Okay.
Or DEFICATE.
I think I know how to spell it. I just don't know what it. Oh, I see. All right. Understood. Yeah.
See, huh?
No,
Not
now I get
bad.
it.
Not bad.
Not bad. Not bad at all.
All right. So what you want to focus on?
We started integrals, and I didn't get it. So I figured that would be good because my teacher had us do 3 weeks of calculus in one lesson.
Awesome.
So we started with integrals though. So
Okay. So you want to just go, let's see. You just want to go with test bank integrals, or do you want me to teach you about integrals? Probably about integrals.
yeah, bit of
If you
both.
don't understand it at all, then we need to do integrals. So
Mm-hmm.
how are you with derivatives though? How do you feel about that?
I feel pretty okay with them. It's just when fractions and stuff get involved that I'm not the best, because of the algebra that I can't do yet.
But it's the fractions.
It's just like the special stuff, kind of like square roots, all of those things I haven't got fully figured out yet. Yeah.
Okay. So let's see. Did he start with Riemann sums, and did he tell you what the integral is, like the area under the curve? Did he talk about that?
No.
Okay, so that's what we're going to do real quick.
Mm-hmm.
So all right. So I'm going to give you the quick version. So we now have the ability to find the area under a curve, right? So this first picture here would be like the total area under the curve from 0 to 1 of y equals x squared, the pink stuff, right? Now we don't have any, there's no formula to find the area of a curve, right? We have rectangles and all that kind of nonsense. So what we started off to do, not us, but the great, maybe you've heard of him, Sir Isaac Newton.
Yes, yes.
Maybe you have
That was
not heard
nice.
of him, Gottfried Leibniz.
Haven't heard
They
of him.
co-founded the calculus. Okay, so, but Riemann started this deal, and that is, okay, we can approximate the area under a curve by using rectangles.
Okay.
By drawing rectangles, because we can find the area of rectangles. Yes. And so from 0 to 1, he said, all right, I'm going to draw 3 rectangles. And these are called left-handed rectangles because the left-hand side of the rectangle is on the curve. Yes. Okay. So, and I'm not sure how much this does come up, so that's why I'm doing it. Okay. So this would be 1/4. He actually did 4 rectangles. I'm sorry. This is 1/2. And this is 3/4. And the rectangle here can't be formed because the top and the bottom are at 0, 0.
Okay.
Okay. So what you do to approximate this is, again, calculate the area of each rectangle. Okay. Now, the area of a rectangle is the base times the height. Yes.
Yeah.
Okay. Well, if you divide it into 4 rectangles evenly, then each base is exactly the same length.
Yes.
So with 4 rectangles, each base is 1/4.
Okay.
In this particular example. Now let me pause because I'm zipping through this because you just need to have this understanding. Okay. And if it comes up in the future where we actually have to calculate it, then we'll do that. Okay. But do you remember when you first started derivatives and you had to do a whole bunch of algebra, first principles? This is kind of the same thing.
Okay.
And we're going to get to a shortcut. Okay. All right. So base is always going to be 1/4, right?
Okay. Yeah.
Okay. So let's take a look at this last rectangle here. So do you agree that this is the height of the rectangle right here?
Yeah.
Okay. And this coordinate where the rectangle hits the curve, the x coordinate is 3/4. Yes?
Yeah.
Right there. Well, to find the y coordinate, I just plug it into x squared, which would be 9/16. Is that okay with you?
Yeah.
3 squared over 4 squared. So the area of this rectangle is 1/4 times 9/16. Yes?
Yeah.
Or 1/4 times f of 3/4, because we plug 3/4 into the function.
Yeah.
And we did it a little backwards here. F of 3/4 is equal to 9/16.
Yeah.
You okay?
Okay.
So if you look here, they did each rectangle, right?
Right.
F of 0, that's this point here. F of 1/4, F of 1/2, and F of 3/4. Yes?
Yep.
So we could actually factor out a 1/4 from each of those. And then it would be 1/4 times F of 0 plus F of 1/4 plus F of 2/4 or 1/2 plus F of 3/4, right? So basically, plugging in the function gives you the height of the rectangle. Okay. And so what this turns into is a summation. Darn it. This turns into a summation represented by the Greek letter sigma. Okay.
Mhm.
Did we do these with sequences and series? Didn't we do these?
Yeah, we did it as well in class like a year
Okay.
ago.
Okay. So usually we use the letter I equals 1 to 4 because we're doing 4 rectangles
Mhm.
in this case of 1/4 times f of, actually in this case it's from I equals 0 to 3 because we start at 0. I'm so sorry, but it's still 4, right?
Mhm.
0, 1, 2, 3. That's 4. That's 4 things. Okay. Times f of x sub I. Well, what is that all about? Well, this is x of 0. 1/4 is x sub 1, and so on. 1/2 of that is x sub 2. Okay, so this would equal, I mean, this produces, this is, so we don't have to write all of that out. This is what this does.
Okay.
And, you know, where we would say where, so the area is approximately equal to where f of x equals x squared, whatever, because that's the function.
Okay.
Okay. Okay, so generally what we do is we say the area, well, I'm going to cut to the chase here. But before I do that, I'm going to ask you, how do you think we could get a better estimate?
Add in more rectangles.
More rectangles, more rectangles. And if we did an infinite number of rectangles, we would get an exact value, wouldn't we?
Yes.
An infinite number of rectangles. And as we get more and more and more rectangles, what happens to the base as we get more and more rectangles? Smaller and 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 smaller. It sounds like a limit to me.
Mhm.
So the area is equal to the sum from, we'll just say I equals 1 to infinity. The limit, I forgot to put the limit as from 1 to n. Sorry, n is the number. Let me rewrite this. So the area is given by the limit as n approaches infinity of the sum from I equals 1 to n of f of x sub I, and we represent the width by delta x because delta makes change, it represents change, and the width is getting smaller, it's changing, smaller and smaller and smaller and smaller and smaller.
Mm-hmm.
Okay? So when we are doing integration, we are finding the sum of an infinite number of rectangles between the curve and the x-axis.
Okay.
These are called Riemann sums because he's the one who came up with this method.
Cool. All right.
And with the limit, we get to this. So here, here's another example so you can kind of see it. Right, you get the idea, all those rectangles, right?
Yeah.
I want to show you the formal definition. Otherwise, I'll get kicked out of the math club. And who wants to be out of the math club? Am I right? Nobody.
Right.
So what we say is this. We rewrite the summation. This is Leibniz's notation. We rewrite the summation formula, this guy, right? The capital letter sigma,
Mhm.
using the symbol that your teacher showed you, this elongated S for sum.
Mhm.
And we say that we can find the area between a curve and the x-axis from between x equals A and x equals B with this, this symbol represents this area,
Okay.
okay? F of x is all the heights of the rectangles in the interval, yes.
Yeah.
Dx is the delta x, which is the width of the rectangle.
Okay.
Okay, and so this symbol we say is the integral of f of x from A to B with respect to x. I usually say the integral from A to B of f of x, that's all.
Okay.
Okay. So what we can say here is where I'm showing you everything, right? To find the integral from 0 to 2 of the function 2x plus 1 dx, well, this is the graph of the function 2x plus 1 right here. It's a line, okay? And so from 0 to 2, between the line and the x-axis is shaded in green, yeah?
Yeah.
So this integral is equal to the area. That's what it's calculating, remember? The area of an infinite number of rectangles gives you all this area, which is a trapezoid. In this case, it's a trapezoid. So this is the formula for the area of a trapezoid, the length of the base plus the two bases, which is 1 and 5, divided by 2 times the height of the trapezoid, and that comes out to be 6.
Okay.
Okay, so you can use geometry. You might be asked to do that. I don't know. Probably not, but you might. So now they're saying, all right, if y equals the square root of 1 minus x squared, or find this integral, right? Now, this is some algebra geometry stuff. This is the formula sort of for the area of a circle.
Okay.
Or I'm sorry, it's not the formula. It's it can lead to the equation of a circle.
All right.
So what they've done is has said, all right, let's find the integral of from 0 to 1 of 1 minus x squared dx, which is just 1/4 of a circle.
Yeah. Okay.
So 1/4 times pi r squared. That's all they did, because the radius of this circle is 1.
Okay. Yeah.
Okay. All right. So that's using graphs. And here is the deal. This is the biggie. And I'll get back to this. So we are jumping leaps and bounds to this. Actually, I'm going to give you just a couple of very simple ones to show you how to integrate. So what I've just told you is the groundwork for the hard stuff of what's actually happening when we do the harder stuff.
Okay.
Okay, which is easy and hard all at the same time, sometimes, whatever.
Mm-hmm.
I'll let you make your own decision.
Okay.
Okay, I just want to have my rules ready for you. And you are SL, that's right. Okay. I have another young lady who reminds me of you who is HL.
No, thanks.
Okay. Here's the story about the integral. The integral is the reverse of the derivative. You go backwards. It's called anti-differentiation. How about that? Anti-differentiation, because we're going backwards when we take an integral. Okay, so for example, if I said, and we're not going to do, well, let me just say this. Okay. The integral of x squared dx. Okay.
Mm-hmm.
This is equal to x cubed over 3.
Yeah.
Okay. You don't need to know how yet, which is equivalent to 1/3 x cubed.
Because you go backwards on the derivative, right?
Yeah.
Okay.
And you can check your answer. Let's just say that y equals 1/3 x cubed. What's the derivative of 1/3 x cubed?
X squared.
It's 3 times 1/3, blah, blah, blah. It's x squared, isn't it?
And there's the unknown value too.
Yes. Well, yeah. So not the derivative. I was saving that. When we don't have any bounds, in other words, bounds would be, okay, all right, let's find the integral from 2 to 4. 2 and 4 are the bounds. Okay. But if we don't have any bounds, then we don't know what it is. So that's this. With bounds is called a definite integral. Without bounds is called an indefinite integral.
Okay.
So we have to say plus some constant c, right? Mm-hmm. Because the derivative of any constant is 0, a constant being a number, 5, 7, 12, whatever. The derivative of 12 is 0. So y prime equals x squared. So we can always check our integral by taking the derivative, and it needs to equal that.
Yeah. Okay.
And we call this the antiderivative. Basically, and
yelling.
I'm sorry.
Do you hear people yelling?
What'd you say? Do I hear people yelling?
Yeah.
Oh. I thought you were telling me I was yelling, because people tell me that like I have a very loud voice. And I'm like, oh my God, no. I'm getting too excited. No, I do not hear anybody yelling.
No. There's a bunch of boys outside applauding and yelling. Someone's probably done a backflip or something.
I bet you $1 if you went out there and gave them a stern look and said, quiet. They would like
They would be
shrink.
quiet.
They would.
Yeah. Yeah. 100%.
They would.
No
I know
doubt.
you
They
have
would.
that. You have that look, right? You could give them the death stare.
Yeah,
Okay.
definitely.
Now, let me rephrase that. You don't look like that normally, but I can tell you have the capability of giving the death stare.
Yeah,
And they would
I think so.
scatter like cockroaches
so.
if you turn on the light in the middle of the night. Scatter.
Right. I haven't had to use it yet, but maybe one day.
Maybe, yes. Okay. So that's the antiderivative. This is called finding the integral. The entire thing is called integration.
Okay.
Or anti-differentiation.
Okay.
Antiderivative. Integration is anti-differentiation. Doesn't really matter.
Okay.
Okay. So here's the good news. On your formula sheet, it gives us a formula. Lot. Imagine that on the formula.
Whoa.
There's a formula. So 5.5 says this. So the integral of x to the n, which is a polynomial, here is the algorithm. X to the exponent plus 1 divided by the exponent plus 1.
Okay.
Plus some constant c. Woohoo! Right? There's run for your life. There's someone creeping out behind you. Oh my God.
Yeah, that's my
Call
roommate.
the cops.
Oh, you're fine. You're fine.
Do you need me to call the cops? Lot. All right. So let's do some more, shall we? So I said, hey, Lot, what up? What's the integral of x to the 6 dx?
X to the 7th divided by 7 plus c.
Boom. Which you also need to be able to recognize as 1/7. Doesn't matter yet. Okay. As far as it actually never matters, it just is more convenient with some algebra, which I know you love, that will come up.
Why is that 1/7?
Well, this is isn't there a 1 in front of this x that we don't write? That we don't speak about, like the relative who comes for the holidays, just for the holidays?
Yeah.
And we need them to go as quickly as possible. That's the 1. Right? If I write x, there's a 1 in front of it. Like 1 times x.
How is that 1/7?
Well, that's equal to 1/7 x to the 7th plus c.
Oh, right. Yes.
Right? That's what I mean.
Yeah, that makes sense.
Okay. Okay, so let's give this a whirl, shall we? So I think that you can totally do this one. Maybe not B yet. Maybe not C yet.
All right.
Okay, but what I'm going to do, because you're going to have these anyway, is I'm going to give you all of the formulas that we have on your formula sheet for integration. Just, you know, they're right after the derivatives. How about that? Isn't that exciting?
Very.
I think it is. So here we go. We've got these guys, and they separate them, which really makes me mad. But who am I? I am no one. And then we have these. So these represents the list of integrals that are given to us on the formula sheet. Actually, I'm going to get rid of that because that comes later. We already know that, actually. So this is our list.
Okay.
So see if you can do A. And I will say the -2 is a coefficient, right? And just like
Yes.
the derivative, it really has nothing to do with the derivative of the variable and the exponent. It's just waiting for something to happen to it.
Okay.
All right, so what do you think for just do the integral of -2x³?
-1/2 to the -1/2 x to the power 4.
Okay, so he did teach you.
Yeah, and the formula, it's quite, you just
Yeah.
add like 1.
So -1/2 x to the 4th. What's next?
5/2x². And then there's an unknown, right?
I'm sorry?
Is that an unknown, the next one?
Nope. Because after that 2,
Oh, that comes a c probably, right?
nope. After that 2 is actually an x to the 0 power. Because x to the 0, actually after the 2 is a 1, right?
Right.
Their ones are
So
everywhere.
it's
2 times 1, right? Because x to the 0 is 1. But we won't
So
think
just
about
2x.
that. I'm sorry.
So just 2x.
-2x plus c. That's A.
Okay.
All right. So B, what do you think?
Oh, it's that last formula, right?
Part of it, yeah.
So 5/x firstly. Was that wrong?
Oh, for B?
Yeah.
Okay, so unfortunately, no.
Okay.
But the good news is this is the easiest integral of all to take.
All right.
Because remember when you had y equals e to the x, what is the derivative of e to the x?
E to the x.
That's right. So what is the integral of e to the x?
E to the x as well.
E to the x. Huh?
Okay.
This is the best news ever. You hate you hate e, but not in calculus. It's your friends, right?
Okay.
And the 5 is just waiting. It's lonely. Yes. All the boys who want to date you, it's very disappointed, just waiting and waiting and waiting. Am I right?
Right.
Okay. You hear that, Partha?
Yeah. Yeah.
He's crying
I'm
now.
sure you heard.
Okay.
Yeah.
So it's 5e to the x. So we're going to put that in our back pocket for a second because we got trouble over there, don't we?
Yes. But there's a formula for that too.
How so?
Oh no, because it's in a root. Never mind. No, there is not.
Well, there actually is, and we already have it.
Can I just move it up and so change the root to x to the power of 1/2 and then 2 multiplied by x to the power of 1/2? Or -1/2, I mean.
Who says you're not good at algebra?
My
All right.
brain.
Now, we already did 5e to the x, didn't we?
Yes.
All right. Get your game on. Here she comes.
Wait, now I'm confused. What am I doing now? Oh, I still have to do that. Okay.
Going back to your power rule here.
And then it's +1, so it's +1/2. So 2 divided by 1/2, which is 1. No, it's not, isn't it?
right? So it's 2 divided by 1/2. No, it's not. It's 4. Okay.
Okay, yeah.
So
That
you
makes
might just do, okay, 2 over 1/2. Oops.
Mhm.
And it's plus, right? Plus C.
Yeah.
Just write it out. Then I'm going to show you something that hopefully will help you. Perfectly fine to leave it like this, but, and you already know.
Yeah.
We could also do this, right?
Yeah.
Okay, so we're going to take a quick timeout here, and we're just going to take a look at the integral of x to the negative 1/2 dx, right?
Yeah.
So in your head, you were amazing. You said, okay, that's x, and what was it? It was 2. We'll put 2 there. So x to the positive 1/2, right?
Yeah.
And it was 2 over 1/2, which is equal to 2 divided by 1/2, right?
Yeah.
X to the 1/2. And when we divide, we actually multiply by the reciprocal of 1/2, which is 2 over 1 or 2, don't we?
Yeah.
2
Sure.
over 1, right?
Right.
Which is 4x to the 1/2, which is what we got before, right?
Yeah. So when you multiply by the reciprocal, you just flip it over.
Yes, it saves you
Okay.
so much trouble. So
Okay.
what I tell folks to do is I say, all right, you got to add 1. Now, negative 1/2 is easy, right? We're good with halves and fourths. We're good with those,
Mhm.
right? But let's just pretend we're not for a second, and we'll do some things that we're not good at. Well, to add 1, aren't I really, can I think of it as adding 2 over 2?
Yeah.
And negative 1 plus 1 is 1/2, right?
Mhm.
So I tell my kids, all right, kids, do that, write your new exponent.
Mhm.
And like you've already discovered, then we're just multiplying by the reciprocal. What's
Yeah.
the reciprocal of that? Oh, it's 2. And you already figured that out. Yes?
Yes.
Okay.
Okay.
You ready though? You ready? You ready?
Yes.
Integral of x, I don't know, 3x to the 7/13 dx. Here, let's do our x, right? And here's 3, just waiting. 3 is just waiting.
Yeah.
So
And
to
it's 20.
integrate, we have to add 1, don't we?
Mhm. Which is 20 over 13, right? And then 3 divided by 20 over 13.
But
So
you're not thinking about that anymore. You have your exponent, you're going to multiply by its
it's reciprocal. So
immediately,
13 over 20. Okay.
right?
Yeah.
So if you get your exponent first, that's the easy part. Because
Mhm.
I'm just, okay, 13 over 13. I can do that. 7 plus
Yeah.
13 is 20. You did it immediately, right?
Yeah.
So then you're like, oh, okay, so that's going to be 39 over 20, x to the 20 over 13 plus c.
Yeah. Okay.
Write down your variable. Write it down, write it down, write it down.
17 over 12 times negative 7 x to the power of 12 over 17.
You went like 8 steps ahead of me. I was about to tell you no, but then I forgot. You are Lot, and the rest of us aspire to be Lot. Right, Partha?
Right. Right, Partha.
Okay, so negative 17 times negative 7 is negative 70 plus 49, which is negative 119 over 12. X to the 12 over 17 plus C. You with me?
Yeah.
All right. So good for you. Hopefully that stays with you. It just makes your life so much easier.
Yeah.
Let's do C. Actually, let's not do C. What is the integral of the cosine of x dx equal to?
Something with sine, but I'm not sure
Why?
because I vaguely remember something with sine.
What is integration? What is it the reverse of?
Derivative.
The derivative. So we're thinking, all right, what function's derivative equals cosine?
Sine? Okay.
Here comes the fun one.
No clue.
What'd you say? No clue?
No clue.
Well, what's the derivative of cosine?
I don't know.
It's negative sine.
Oh, okay.
Do you remember that?
No.
So if y equals cosine x, y prime is negative sine x, right?
Okay.
So if I just wrote cosine x here, yes?
Yeah.
The derivative is negative sine x, isn't it?
Yeah.
Well, I need this, okay, plus c, sorry, plus
Then
c.
it's negative, right?
I need to make this negative, don't I?
Yep.
And they're there for you anyway.
All right.
They're here for you, but I wanted you to be able to think it through. They're
Okay.
on your formula sheet for sine and cosine, okay?
If there's a coefficient or like a multiplied by a number, does that just stay?
Who are the coefficients, Lot? We've been over this. The coefficients are like Partha. They're waiting, they're lonely.
Right.
They're
Okay.
waiting for you, Lot.
Right. I'm
A
sure.
long wait. It's a long wait.
Yeah, that makes a lot of sense.
I don't even know the young lad, and I'm just killing him. Coefficients, it's the same. Integrating is the same as differentiation. All the coefficients, they do nothing. They wait for whatever happens, then they multiply or divide or whatever. It's a sad, sad
Okay.
story.
Okay.
All right, so what do we got?
Negative 2 cosine x. And then minus sine x plus c. Oh yeah. Yeah.
Feeling any better? Feeling any better?
Yeah, that's a lot simpler than I thought.
So the only thing we haven't done is this guy right here, the integral of 1 over x. He is equal to the natural log of x.
Yes, those two straight lines, is that absolute value?
It is, because we cannot find the natural log of a negative number. That does not exist. So
I just make it positive if it is negative.
it's just, it rarely comes up. Okay.
Okay.
It just has to be there to be mathematically correct.
Okay.
As we progress, there might be some instances where it comes into play.
Okay.
But we need to put it there until we don't. How's that?
Sounds good.
It's in the mathematics compute. Well, I won't say that. I won't say it. Okay.
Okay.
All right. So let's where are we time-wise? Isn't it amazing when you're having so much fun with calculus, how quickly the time goes?
Right.
Yeah, I know.
All the time. Yeah.
All the time. Right, Partha? Oh, wait, who's the other lad? What's his name?
Oh, Filippo.
Filippo. I haven't forgot you, Filippo, just your name. So Filippo, after all of that, what if I had the integral of 2 times 1 over x dx? What would that equal?
Two x divided by. Is it?
This is a coefficient.
Oh, because you're adding 1. Oh, never mind. Never mind.
2's a coefficient. Remember, we talked about
natural log. 2 natural log.
Yep. 2 natural log absolute value of x plus c.
Where did the 1 over go?
The integral of 1 over x.
Yes, got it. Okay.
Right?
Yeah.
All right. Now, here's the sad thing, though. You're never going to see this integral as 2 times 1 over x.
Okay.
Okay, so off to the side in red, Partha, you're going to tell me, forget about this integration. This is just arithmetic / algebra. What is 2 times 1 over x equal to? How would I write that more simply, perhaps?
2 over x?
Yes, that is how it's going to appear, young Partha. It will not be this. It will be the integral of 2 over x dx.
Okay.
Which we either need to recognize immediately as 2 times 1 over x, or perhaps we write it to remind ourselves.
Okay.
Furthermore, and I haven't done this with the others, with any coefficient, I can factor it out if I want to. And then it's more clear that it has nothing to do with anything.
Okay.
Like Partha and Filippo. Filippo or Filippo?
With an O, yeah.
That's it?
Just O. Yeah.
I would be with flourish.
Yes.
I don't know. Equals to natural log abs x plus c.
All right.
Smell what I'm cooking?
Yes.
Picking up what I'm putting down?
Picking it up.
Stirring what I'm cooking? Oh, I already did a cooking thing, so that's no fun.
Yeah.
Oh, that's HL. Oh, so you don't have to do that.
Great.
I'm going to
Whatever it
show
is,
it to you anyway. I'm going to show it to you anyway, just so you're like, oh, thank God. Look at B and C.
Oh, I've seen that on some HL's homework.
Yeah. It's actually not that bad, but it is, but it's not, but it is.
Yeah, it looks bad.
So we shall say away with thee, and we shall focus on A and integrate with respect to X. So basically they're just saying, all right, what's the freaking integral of -2 over X plus 3e to the X? With respect to X, we call that the dx, but we also remember that is the width or the length of the base of the rectangle, right? Because this is an elongated S, meaning sum, meaning the capital letter sigma.
Yes.
Okay.
Right. Can I move that x up first? Is that right?
What do you mean?
Like -2x to -1. Oh, yes. -1 times, no, -2 times 1/x.
No,
Is
times
what
the
I'm gonna
natural.
turn
I
that
already,
into.
oh, you're rewriting it.
Yeah.
So sorry.
Yeah. No,
I'm
that's all
sorry.
right. It's just it for my brain. And then +3 to the x. So then I would do -2 natural log x.
I know you meant to say absolute value. I forgive you.
Yes, my bad. Plus, oh, that's over there. 3e to the x plus c. Yeah, big smiles.
It's no longer big yikes.
No, no.
It's hella fun.
Yeah, this is great.
No, it's hella great. It's not, come on. I'm trying to make you cooler than you already are, Lot.
Sorry, I
Trying
can't
to
do
help
that.
you out. All right, so, ooh,
That scares me.
okay, we're just gonna have some fun. Ready?
Yeah.
What do we got? 3:18. We got 12 minutes of fun ahead of us.
Great.
So give me a minute and I'm just gonna. Just preparing for the fun. How's that? All right, there you go.
All right. Four x to the third divided by 3. Plus natural log absolute value of x plus c.
Again, she is Lot and the rest of us wish we were Lot.
Two x to 1.5 over 1.5, so 3/2.
I like to do this. I like to rewrite it,
Okay.
right? To get it to where it's integratable.
Okay.
You with me on this now?
Yeah.
Okay. I always write the variable, but you nailed it. You got it in your head. So anyway, go ahead.
2x to 3/2 over.
Stop saying over.
Oh,
I want you to write this
no,
first.
multiplied, so 2/3 times 2x to the 3/2
Okay.
minus 2 times 3x to the 1/2 plus c.
Then we clean it up. Unless you're very confident, which it seems like you are.
Yeah. Okay.
So now the trick is, as you become proficient at integrating, all of a sudden you're going to have to be able to integrate and differentiate, integrate and take the derivative, and keep it straight, right?
Yeah.
But you have your formula sheet, don't you?
Yeah.
And before you know it, you won't need your formula sheet. Doesn't that sound great?
Yeah, sure.
Sounds peachy. It sounds top shelf. No
I've
cat.
never had that. Yeah, yeah.
This is what I was saying big yikes about, sort of.
Yeah.
But I have faith in you, Parth. I have faith in you, Philip.
Oh wait, I think this makes sense. So it would be natural log 3x.
No.
Nope, 3 natural log. No, wrong. Never mind.
Oh, that's terrible. Doesn't it?
Yes. Okay. So then it's 1/3 natural log x minus 2x to the -2.
I actually have to write it out because I'm always scared that I'm going to screw it up.
Okay.
So it's not you, it's me.
Okay.
Now I need the variable, or yeah, the exponent.
-1, and then add the 2, the -2, and divide all of it by -1.
Or multiply by -1, right?
Right, multiplied by -1. So you can just take out that +1. Oh no, it's not. Never mind. I misread it.
Yes.
Yes, that makes sense.
If need
Wait,
be.
so I can multiply if the power is -1, I can just multiply it by -1.
You mean out in front?
Yeah.
Yeah, whatever it is. Because the reciprocal of -1, right,
Oh, it's just
is
you
1
flip it to
over
something.
-1, which is -1.
Yeah. Okay. So let's say it was 2. I could do 1/2. Okay.
-1/2.
Yeah.
If it was -2, it would be -1/2, right?
Yeah.
The reciprocal of -2 is -1/2 is what I'm trying to say.
Yes.
Oh, Parth. I'm thinking of poor Parth all alone. He's not going to be able to do it. He's going to cry so much.
Filippo's got it.
Filippo's on it?
Yeah, he's been in class and he gets things right all the time. And he said, that's all Dave. Okay. That's the same as 2x to the 1/2? No? No, it's not. X multiplied by x to the 1/2.
Who says you don't know your algebra? A little bit more work to do. X to the what?
X to the x squared divided by 2.
No, we can't integrate something times something. We can't integrate a variable times a variable. We don't know how to do it. We need it to make it one variable.
Right. Oh, x to the 3/2, but that +1 is x to the 5/2.
Let's do this. I'm so afraid you're going to make a silly error, but you haven't made one yet. All right. So we're integrating now, right?
Yeah.
What's our
So-
exponent?
5 halves, and in front of that, 2/5.
Bam.
Yeah, okay.
See how
And
easy that
then-
is?
Yeah, it's pretty easy. Much
Yeah.
better. Okay. And then minus -9x. And that's it. Yeah.
Anytime you see just a constant, it's, you don't, boom, you slap an X on it, don't you? Okay, I think we have time for one more.
Um,
What's my exponent?
that's -1/2, right?
Yes.
Okay. And then multiply 3x by -2. And then plus x to the 5/4 multiplied by 4/5. So that's -6x instead.
Yes.
Yeah.
Yes.
No, not really. I wouldn't have done that.
Well, you have to be able to.
Yeah, I don't know.
You don't, okay, so X to the M over N is the same thing as the nth root of X to the M,
Okay.
or the nth root of X to the M. The M can be inside or outside.
Okay.
So this could also equal -6 over square root of X plus 4/5 times the 4th root of X to the 5th inside plus C.
Okay.
The reason you have to do that is you have to be able to do that is we are going to be plugging in numbers for X. That's what we do with definite integrals. And so I'm thinking if you had like 16 to the 5/4, you can't do that in your head. I can't. Well, I probably could, but I don't want to. And I always rewrite it. Okay, the 4th root of 16, okay, that's 2. Because 2 times 2 times 2 times 2 is 16, right? And then it would be 2 to the 5th power, which is 32. So something, I'm sorry.
Is x to the 5/4 the same as 4/5 times x?
No,
No. Okay, never mind.
it's the 4th root of X to the 5th. It's not
Okay.
the same thing.
Okay.
So I'm just giving an example of how that could be a legit non-calculator question where you would have to evaluate this for X equal to 16, because you plug 16 in here, right?
Yeah.
Well, square root of 16 is 4, no big deal.
Yeah.
You plug X in here, the 4th root of 16, like I said, is 2. Raised to the 5th power is 32.
If I put the power of 5 inside of the root, do you end up with the same answer? Let's say you did 16 to the power of 5 and then you took the 4th root of that.
Yes, you do. But that's why we don't want to take 16 to the power of 5, do it. So when we see that, we're going, I'm going to do this.
Okay.
Okay.
Yeah, got it.
Well done.
Thank you.
Well done. We will see you in a week. Is that where we're at now?
Yeah. Yeah.
Next week, you have the time change,
Yeah.
right? So I
Mhm.
think we're back to noon or one. I can't remember.
I think so. I have to check, but
Let
I
me,
will let you know.
I'll tell you what I have on my calendar for next week. I have you at noon, my time, Eastern Daylight Time.
Okay. Yeah, that makes sense.
So can you or mom let me know if that's not the case?
Okay. Yeah, I can make that either way. So that's fine.
Okay. All
Yeah.
right. Have a great week.
Thank you too.
All right. Bye-bye.
Bye.